Hello everyone. In this video, let us attempt to prove that the square root of 1 plus sin a divided by 1 minus sin a is equal to secant a plus tan a. Now we'll have to prove that this left hand side is equal to secant a plus tan a. Now looking at it for the first time, one might wonder that the left hand side consists of sine. It has sine a, and whereas the right hand side has secant and tan, different trigonometric ratios. So one might be left wondering how to go about it. So let us try to explore the right hand side of this equation further. Let's start with secant a plus tan a, and let's see if whether this gives us an idea of how to go about this proving. Secant a plus tan a can be written as 1 by cos a, because secant is a reciprocal of cosine, so we can write secant a as 1 by cos a, and tan a can be written as sin a by cos a, right? Now let's see if this helps us. Of course, till now it doesn't help us in any way as to how to go about the problem. So look at it further. Now the denominators are same for both 1 by cos a and sin a by cos a. As the denominator is cos a, we can just add the numerators. So this gives us 1 plus sin a divided by cos a. And now if we compare the left hand side of the original equation which was given to us, which we were supposed to prove, and when we compare that to what we have arrived at now, 1 plus sin a by cos a, we see that the numerators are almost the same, but for the numerator of the left hand side is within square roots. So this should be giving us a hint. Now all this what I have done with the right hand side is just an idea to help us on how to go about the problem. Let's consider this as an intuition, to give us an intuition on how to proceed with the problem. So we have an idea now. We can try and multiply the numerator 1 plus sin a, the square root of 1 plus sin a, by once again by 1 plus sin a, because this is what we have got from manipulating the right hand side. We have a 1 plus sin a in the numerator, so let's try to multiply, but we cannot just multiply like that, because we'll have to multiply with the same value the denominator also, otherwise the fraction will be altered. So if we do not want the value of the fraction to be altered, and we do not want also, it should not be altered, the value should remain the same, so we are multiplying both the numerator and the denominator by 1 plus sin a. And now what does this give us? This is equal to the square root of, the numerator is just 1 plus sin a the whole squared, right? Because it's 1 plus sin a into 1 plus sin a, it's 1 plus sin a the whole squared. And what about the denominator? Now the denominator, if you observe, it is of the form a minus b into a plus b. 1 minus sin a into 1 plus sin a, and if you recall the algebraic identity, this is equal to a squared minus b squared. Even if you don't recall, you just multiply and see, and you will arrive at this result. So now we have 1 minus sin a into 1 plus sin a would be equal to 1 squared minus sin squared a, right? And 1 squared is nothing but 1. So let's erase this square here. So we just have 1 minus sin squared a, and all of this is within the square root sign, right? So this is also within the square root. Now what is this 1 minus sin squared a? How can we go about it? Now we'll have to recollect the Pythagorean identity. Sin squared a plus cos squared a is equal to 1. We have proved this in one of our videos here in Math Decoded. Sin squared a plus cos squared a is equal to 1 is the famous Pythagorean identity in trigonometry. And with this, now we have 1 minus sin squared a, like it's just rearranging. You shift sin squared a to the other side of the equation, you get 1 minus sin squared a is equal to cos squared a. So let me rewrite the whole of the LHS as the square root of 1 plus sin a the whole squared divided by cos squared a. Now, what have I achieved by substituting 1 minus sine squared a by cos squared a? I just have a square in the denominator also. Already we had a square in the numerator, 1 plus sine a the whole square, and now we have cos a the whole square in the denominator also. So now we have a direct result. Just finding the square root of a square, you have this is equal to, eliminate the square root, we have this is equal to 1 plus sine a by cos a. And now let's compare what we have here and what we have in red here, which was just done to provide us an intuition on how to go about the problem. It is equal. So, but we're not going to say because this is equal we have solved the problem. We'll see how we get the right hand side of the initial equation, secant a plus tan a, from here. So we just retrace these steps. Now we got this from here. Let us retrace these steps one by one and arrive at the right hand side. So now we have 1 plus sine a by cos a. Now let me split it and write it as 1 by cos a plus sine a by cos a. And what is 1 by cos a? We know the cosine, the reciprocal of this 1 by cos a is secant a, plus sine a by cos a is tan a. So now we have the right hand side of what we were asked to prove originally. So we have proved it. We have proved that LH is the square root of 1 plus sine a by 1 minus sine a is equal to secant a plus tan a. And remember, we did not memorize anything here. Normally what children do, they repeatedly do the problem, work out the problem 5 or 6 times and arrive at the result so that they are able to reproduce it in the examination hall, which is not at all advised. You may proceed with the right hand side just to give you an intuition on how to go about the problem. And I recommend that you follow our videos in Math Decoded, which will help you not to memorize but to understand and do every problem, attempt every problem in a logical manner. Thank you. I hope you understood.